Hello everyone. So today we are going to solve the problem of the day of GFG, which is unequal arrays. So in this problem, we are given two arrays of length n, and we can perform the following operation on the array A on 0 or more times. So we have to select the two indices I and j, which can't be equal. As you can see, I not equal to j. And the second thing is we can increase the array element of array A by 2 and decrease the other array element by 2. So let us look at the node part. So two arrays are said to be equal if the frequency of each element is same. So we have to make the two arrays which are given as input the same, and we have to find out the minimum operations required to make them equal. So this is the another point, that is we can have multiple same elements in the array. So let us look at the first test case. So in the first array A, we have so 256, 2, 5, and 6. And in the second array, we have elements 1, 2, and 10. So the first thing is we can the as you can see, the sum of the two arrays, the sum of this array and this array should be same. All right. And for converting an element from, suppose how they have did in the first test case, let us look at that, then I will explain. So they, since 2 is already present in the both arrays, so we will not touch it, we will not touch this element. So for 5 we can decrease this 5 by 2 and increase this 1 by 2. So what do we get? We get 3. So we have uh, made these two elements as equal. So our task is finished for this element. So the rest is 6 and 10. So let us increase the 6 by 2, and 10, let us decrease it by 2. So we will have 8. So yeah, by performing two operations, so this is one operation and this is the second operation. So uh, by performing two operations, we have mm, we have made these two arrays equal. So what is the catch here? So for every two units of 2 means adding and subtracting. We are adding and subtracting at the same time. For one operation, we are we require 2 units of 2, increase and decrease. All right. So one operation takes +2 and -2. I hope you understood how this works. And for two operations, we have we will be doing +2 and -2 -2. So yeah, 4. 4 units of 2 we require for two operations. Similarly, for uh, three operations, we'll be requiring 6. 6 tools. That is increasing a number by 2 3 times and decreasing the other number by 3 times. So yeah, that's how. So let us look at now the first test case. So we have 2, 5, and 6, and 1, 2, and 10. 1, 2, and 10. So we can convert the one element to the other element of the array if and only if the both of them are, since as you can see, we can add 2. We can only add 2, all right? So we can convert one element to other if and only if both are even or both are odd. You can see if 1 and 5, so as you can see, the difference between them is 4. So we can increase an element by 2. Suppose we have increased 1 by 2 and decreased 5 by 2. So we have made it 3. All right. So Same goes for 6 and 10. The difference between these two is even, so we can do it. We can convert them to uh, to we can make them equal, right, by performing operations. So that's all. That's the catch here. So there are two things. The sum of these two arrays should be same, and the elements we are converting, suppose 5 and 1 and 6 and 10, should be even. All right. So, and we will be sorting for uh, for the sake of simplicity. We will be sorting so that the closest element we get the, suppose we have, suppose if this test case wouldn't have been 256 and would have been 6 5 and 2 and 1 2 and 10, 1 2 and 10. So as you can see, difference between these two. So let us not consider this case, this test case, or we can see, or we can consider this one as 6 and 2. So we would have been decreased this 6 by 2. This would have been 4, and increase this 2 by 2. This would have been 4, and the solution would have gone wrong. So for the simplicity, for the sake of simplicity, we will be sorting these two arrays. So we will be getting the optimal solution. All right. So let me code this for you. So we'll be requiring, since as you can see, the constraint lie from 10 raised to the power minus 10 to the power 9 to 10 to the power 9. So we'll be using long variable, initialize it with 0, which will be holding our the total number of operations, right? So, and we will be long sum 1, since the sum of the two arrays should be same, right? So, yeah. So let's traverse from the in the first array, and let's calculate the sum, and sum 2 plus equals d of I. So we have got the sum. Now let us let us uh, separate the odd elements and the even elements of the array. All right. The reason why I will be telling you afterwards, from the code you will understand. So if a of I mod 2 not equals 0, then what are we going to do? We are going to make four vectors, vector int a odd, comma a even, comma b odd, and b even. Right. So yeah. Mm, so not equals 0. So we will pushing it in a odd vector. A of I dot a odd dot push back a of I. Else what we're going to do? We're going to push the element in the A's even vector. So push back a of I. Similarly, we're going to push the odd elements and even elements of the array B. So we have got the even and odd elements segregated. So now what we're going to do? We're going to check if sum1 not equals to sum2. If it is not so, or the number of even elements a dot a even dot size is not equals to b even dot size. Then we return. Then what we have to return? We have to return -1. So as you can see, the number of even elements 3 and 3. The number of even elements is 0 and odd elements is 2 in the array A. and the number of odd elements. So at the end of the day, we have different odd and even elements in this two. So it is not possible to convert. As I already told you, we can't convert one odd and one even element. So we return -1. Else part, what we're going to do? So we are going to traverse. Uh, so we are going to traverse in the a even array dot size I plus plus answer plus equals to absolute of the the reason of taking the absolute value is because since we are taking the difference, right, and we don't need any negative value, since the number of operations we are performing should be positive, should be a positive value. So that's why we are taking the absolute of a events of a even of I minus b even of I. The even element of array A minus the even element of array B. So let me explain it through a example. So for example, we have the A even vector contains 2 comma 5, 2 comma 6, and B even vector contains 2 and 10, 2 and 10. So we will be traversing in this array, all right. Since the size of both the vector A even and B even is same, we have already checked, all right. We have already checked, and if it is same, so we will be traversing in any one of them, and and calculating the answer as answer can be given as 2 minus 2, 2 minus 2. So since the difference between these two is 0, so there is no need to perform any operation in order to make them equal. So when we have to make both the elements equal, when we have the two elements unequal, all right. So let us take 6 and 10, 6 minus 10, sorry, A even is 6 minus 10 and its absolute value, its absolute value. So we get 4. So we require 4 divided by how many operations? 4 divided by 4, because we require 4 units of 2. So we are going to add a 2 to 6 and we subtract a 2 from 10. So 2 comma minus 2. So we require 4 units of 2 in order to make the both of these elements equal. So the absolute value of A evens and the B even. Similarly, in case of odd, A odd or B odd. And in the end, we return the answer divided by 4. Since it requires 4, as I have already told you, it requires 4 units of 2 for one operation. So let's compile. So let's submit our code, and it's giving wrong answer. So we may have answer plus equals divided by 4, grade of 2 grade of 2 from 1 from 2 Oh, we haven't sorted the array. Comma a dot n. Similarly, we will be sorting the b array as well, the b vector. Yeah. Let's submit the code. And yes, it has got accepted. So if you have any doubt, make sure you comment below. I will try to resolve it. Thank you.